Okay, now I'm going to teach you how to name ionic compounds that have more than one oxidation number. I will always tell you when this is the case. I'll let you know, hey, this is a question or a problem that needs Roman numerals. And when we have to do these, we still go through the same steps, but we just have to do a little extra work once we get to the nitty-gritty. So I'll take you through this. So the first step is to count the number of elements. And I have two elements, Cr and Cl. If there are more than two, then we have to follow different rules. There are not more than two. If there are only two, there are, so I have to determine whether each is a metal or a nonmetal. So Cr is a metal here in family 6, and if you'll notice, it does have more than one possible oxidation number. So that's another giveaway rule. And then Cl, that is a nonmetal. It's in family 17. Step 4 says if there are two nonmetals, use those rules. There are not two nonmetals, so we're going to skip that. And step 5 says if it is a metal and a nonmetal, follow metal to nonmetal rules. So we're going to go below and follow metal to nonmetal rules. So I'm going to name my metal first. That's chromium. And then in parentheses it says if the metal has more than one oxidation number, see directions below. The directions below it's referring to are these very wordy and detailed directions that I wrote out, hoping that if you weren't with me and you needed to figure it, but I'm just going to take you through it on my own right now. So basically, because chromium can either be +3 or +2, we need to figure out which chromium we're dealing with in this compound. Are we dealing with chromium with the +3 charge or with the +2 charge? So what we have to do first is we have to figure out the total charge coming from the nonmetal, because the nonmetal only has one oxidation number, so it has a set charge that's coming from it. So I'm going to do a little math. See, science and math just are interrelated. Isn't that awesome? Okay, so I have 3 chlorines right here. So I'm going to put 3 times, now I need this, 1 negative, or -1, you could say it either way, that's fine, equals a total of -3 coming from chlorine. Now because compounds like to be balanced, I need the opposite charge coming from chromium. So if I have -3 coming from chlorine, I need +3 coming from chromium. So I'm going to put that over on this side. And I'm just going to do a backwards multiplication problem. I'm just going to work backwards. So if I need a total of +3 coming from chromium, I'm going to look and see how many chromium atoms do I have in this compound. Since there's no subscript written, that's that small number, then I can assume that there is 1 chromium atom, because there's the symbol chromium, so obviously there's at least 1. If there's more than 1, they'll always have a subscript with 2, 3, 4, whatever. So there's 1 chromium. So what times 1 equals +3? What's the chromium with the +3 charge? Now in this example, the charge for the individual chromium equals the total charge coming from chromium, but that's not always the case, so please don't be confused by that. Don't think that that's always the case. Sorry about that. That was the bell. So we're going to write chromium with the +3 charge, so we're going to do Roman numeral 3, and then we're just going to end it with chloride. And that's how you name ionic compounds with Roman numerals.